We are at the top of the hour, so we'll go ahead and get started with our webinar. Hello and welcome. My name is Melanie Ross, and I will be your presenter for our webinar today. You'll notice we also have Patrick Seelig and Chris Fox-Strauss with us today to assist with the question and answer session after the presentation. Patrick and Chris are both senior managers of accreditation in our inspection, laboratories, and related activities business unit. My formal title is Technical Products Developer for ANAB. Thank you for joining ANAB for our complimentary webinar on in-house calibrations for testing laboratories. Some logistics before we get started. Due to the number of attendees, everyone will remain muted for the duration of the webinar. Please enter your questions into the Q&A box. We have planned time at the end of the webinar to answer any of the questions that you may have. Additionally, please note that we are recording this webinar, so it will be available for viewing on our website in the future. The key takeaways for our webinar today is to gain an understanding of the basic concepts of calibration, traceability, and uncertainty in the context of the ISO/IEC 17025 standard. We're going to look at some of the pros and cons of doing calibrations in-house versus outsourcing those calibrations to an accredited calibration service provider. We'll talk about what general equipment, standards, and records are needed for an in-house calibration program, and learn how to show staff competence and stay in conformance with the 17025 requirements. Finally, we'll talk about some of the common pitfalls and how to avoid them to mitigate risk. Starting with our basic concepts, we need to understand when equipment should be calibrated. The 17025 standard in clause 6.4 states that measuring equipment shall be calibrated when measurement accuracy or measurement uncertainty affects the validity of reported results, and/or the calibration of equipment is required to establish metrological traceability of reported results. So when we think about this requirement or these two requirements in the standard, almost all of the measuring equipment that a testing laboratory uses would likely need to be calibrated because uncertainty of the measurement accuracy can impact the validity of the reported results. And for most measurements that laboratories are making, metrological traceability is important for those reported results as well. Before we go on any further, we should probably define what measuring equipment is. Measuring equipment can be direct measurement of a measurand. It can be used to make corrections to the measured value, and it also can be used to obtain measurement results calculated from multiple quantities. We could think about a balance that's used to perform a mass measurement or equipment that's used to measure temperature. Continuing on with our basic concepts, the 17025 standard provides a general framework for calibrations in clause 6. The laboratory should establish a calibration program and review and adjust that program as necessary. The point of the calibration program is to maintain confidence in the status of the calibrations of the measuring equipment. Our next basic concept is traceability in clause 6.5. As you remember, measuring equipment must be calibrated when metrological traceability is important to the results. The standard requires laboratories to establish and maintain metrological traceability of measurement results and ensure measurement results are traceable to the International System of Units, or the SI, or an appropriate reference. We can define metrological traceability by looking at ISO/IEC Guide 99. It is a property of measurement result whereby the result can be related to a reference through a documented, unbroken chain of calibrations, each contributing to the measurement uncertainty. When we look at traceability to the SI, there are different options within the 17025 standard to obtain that traceability. The first is calibration of measuring equipment provided by a competent laboratory. The second is certified values of certified reference materials provided by a competent producer with stated metrological traceability. And the third is direct realization of SI units ensured by comparison with national or international standards. The standard uses the statement competent laboratory. When we're looking at the calibrations of equipment, laboratories fulfilling the requirements of the 17025 standard are considered competent. This allows for in-house calibrations where testing laboratories are not necessarily accredited for calibration activities, but they do conform to the requirements of the standard for calibration of equipment, metrological traceability, measurement uncertainty, and reporting results. It's important to refer to your accreditation body requirements to determine how they consider the term competent laboratory. When looking at traceability to an appropriate reference, the certified values of certified reference materials provided by a competent producer can be used in this case. When we're looking at the term competent producer, in this case, that would be an organization that meets the requirements of 17034, the conformity assessment standard for reference material producers. Traceability can also be to an appropriate reference through results of reference measurement procedures, specified methods, or consensus standards clearly described and accepted as providing results fit for intended use ensured by suitable comparison. This traceability to an appropriate reference would be used when traceability to the SI is not possible. Again, you would want to refer to your accreditation body requirements for accreditation to 17034 and when that is required for certified reference materials. Moving on to our next basic concept of uncertainty, the standard provides in 7.6.1 that laboratories need to identify contributions to measurement uncertainty, including all that are significant, including those from sampling. Testing laboratories need to keep this in mind if they are pulling calibrations in-house, because it's important to have measurement uncertainty for the calibrations that are being performed. Oftentimes, testing laboratories, will use their controls to determine measurement uncertainty for the tests that they're performing on client samples. Measurement uncertainty for calibrations is a bit more complex, so testing laboratories need to understand the measurement uncertainty requirements as well as how to develop an uncertainty budget for the calibrations that they are performing. Then, in 7.6.2, the standard requires an evaluation of measurement uncertainty for all calibrations, including those of your own equipment. When outsourcing calibrations to an accredited calibration service provider, the service provider evaluates measurement uncertainty for the calibrations of the equipment in the laboratory. If the laboratory pulls the calibrations in-house, they would then need to evaluate that measurement uncertainty for all of the calibrations performed. Again, that includes the own equipment of the laboratory, which is where the standard provides for the ability of testing laboratories to bring calibrations in-house when it makes sense. When looking at in-house versus outsourced calibrations, there are pros and cons to each. When you're looking at in-house calibrations, you need to ensure that the calibrations conform to the relevant requirements of the standard. You also may want to consider having tailored resources. What this means is resources within the laboratory that have the competence to perform the calibrations of the equipment within the laboratory. Sometimes this can be a risk to organizations, which we'll see when we start talking about risk. One of the benefits of having in-house calibrations is greater control over the equipment and the calibrations being performed. The laboratory can schedule the calibrations within their typical workflow and can perform calibrations on equipment that may be out of calibration more expeditiously than having to schedule it through a calibration service provider. However, there are benefits as well for outsourced calibrations. This will ensure, if your calibration service provider is accredited, that your calibrations comply with the requirements and that your equipment will provide the necessary metrological traceability and have measurement uncertainty associated with those calibrations. Calibration service providers have dedicated resources that are trained and capable of meeting the requirements of the 17025 standard. An important aspect of outsourced calibrations is contract review to ensure the calibrations that you are purchasing from the calibration service provider are what you expect and what your organization needs for the requirements of your testing methods. I do want to take a second here to talk about what is in-house calibration and what is not. Plain and simple, in-house calibration is not the verification of equipment that testing laboratories perform on a routine basis. This is not the intermediate checks of equipment that are performed as well. Calibration is calibration, or in-house calibration is calibration of equipment supporting tests and measurements on the scope of accreditation. It is ensuring that the equipment is functioning properly and that it meets the intended needs of the equipment. It also provides that measurement uncertainty and metrological traceability again. Diving into the pros of in-house calibration a little farther, in-house calibrations can help reduce cost, minimize downtime, improve quality control, and decrease turnaround times. When looking at reduction of costs, however, the laboratory needs to consider the resource requirements to perform the in-house calibrations. If the laboratory does not have personnel that are capable of performing the in-house calibrations, it could increase cost in the beginning in order to train personnel to perform those calibrations. Minimizing downtime is because the equipment can be calibrated on site in line with the laboratory's testing schedule. Equipment doesn't have to be mailed out and sent back, which could increase or minimize downtime. As far as quality control, the laboratory is most familiar with the equipment that they are performing and the equipment they're using and the calibrations that they need. They could then tailor the controls that are used for the calibrations to ensure that the equipment is functioning for the methods that they are performing. And again, in line with minimizing downtime, it can also improve turnaround times because equipment can be calibrated in downtimes of the laboratory or in between projects, so to speak. Going further into the reduction of costs, it may eliminate external service fees where applicable. It can assist in improving operational efficiency as well. Because the calibrations would be performed in-house and could be calibrated on a more frequent basis, it could extend the lifespan of the equipment. Again, I've mentioned before, you could customize the calibration schedule based on usage of the equipment as well. For minimizing downtime, it does reduce transportation time and could enable the laboratory to schedule calibrations during off-peak times. With that said, that could also be organized with an external calibration service provider as well. So that's something to consider if you're looking at in-house calibrations versus outsourced. And then as well, it could have a faster return to service of equipment for equipment that no longer needs to be sent out to a calibration service provider. When bringing calibrations in-house, one thing the laboratory can consider is a more proactive maintenance strategy. It can help identify and resolve issues more quickly with equipment if there are individuals in-house that have the capability to calibrate and maintain equipment. can also allow for better management of specifications related to the requirements and can prevent failures that lead to downtime. For turnaround times, it could simplify scheduling and eliminate shipping delays, and overall provide a greater control over processes with a rapid response for critical equipment. There are downsides of in-house calibrations and many benefits for contracting equipment calibrations as well. Having the equipment and the standards needed to perform the calibrations could be prohibitive in cost and feasibility for the laboratory. Record keeping is another thing to consider when looking at in-house versus outsourced calibrations. Accredited calibration service providers conform to the requirements of 17025 for the control of records, including technical records such as the calibration reports. This is something that the laboratory would need to consider in determining if in-house calibrations are feasible. Additionally, there are other requirements in the 17025 standard that are specifically pertain to calibration service providers. Testing laboratories need to be aware of these requirements and conform to those requirements for their in-house calibrations. And one of the cons that I mentioned before is competence of personnel. If the laboratory does not have personnel available to become competent in performing the calibrations, outsourced calibrations would make more sense. In general, companies must have sufficient scale to justify the investment in in-house calibrations versus outsourced. Ensuring that the ensuring that the laboratory has the appropriate equipment and standards is of utmost importance in addition to personnel competence. Laboratories must have the reference equipment and reference standards needed to perform the in-house calibrations. Additionally, as I mentioned, record keeping is important for calibrations regardless if they're in-house or outsourced. There are two different types of records that the laboratory must maintain. Within the laboratory, equipment records, including the identity and manufacturer of the equipment, any verifications that were performed, locations, calibrations, etc., must be maintained. Additionally, for calibrations performed, calibration records must be readily available that can contain the measurement uncertainty for the calibration, as well as the conditions under which the calibration was performed. Metrological traceability must be included in the records as well, along with the results before and after any adjustments. And then, if applicable, a statement of conformity would also need to be included in the calibration records. There is a third type of record that must be considered in relation to in-house calibrations. Anyone involved in the calibration process must have personnel records on file that document the competence requirements for performing those calibrations. Additionally, records must be available for the selection, training, and supervision of personnel, as well as the authorization of personnel to perform the calibrations. And finally, there must be records on hand with competence monitoring of all individuals that are performing the calibrations. This is something the laboratory must keep in mind that would be in addition to the competence records for the testing and measurements that are performed within the laboratory. When looking at requirements that require conformance with the 17025 standard for in-house calibrations that are above and in addition to conforming to these requirements for the testing that is performed, are those requirements related to measurement uncertainty and metrological traceability, as well as a defined period of validity for the equipment that is being calibrated. Intermediate checks must be documented, defined, and recorded as they're performed, as well as any reference values or correction factors where applicable. There also needs to be consideration of unintended adjustments of equipment. Testing laboratories conform to this requirement, but there are additional considerations when calibrations are being performed in-house. And then, as I stated previously, the additional record control requirements for calibration records and reports would need to be implemented in the laboratory. Additional requirements would include a procedure for handling, transport, storage, use, and planned maintenance of equipment. Well, this is a requirement of all laboratories conforming to the requirements of 17025. The testing laboratory would need to consider these steps for calibration equipment and equipment that is being calibrated in-house. Additionally, procedures for the calibration of equipment would need to be developed, implemented, and maintained. When looking at competence of personnel, there are some considerations to keep in mind. Personnel involved in in-house calibration should have the technical ability to calibrate equipment, as well as an understanding of measurement uncertainty and metrological traceability. Additionally, personnel must be authorized to perform calibrations and to report the results of those calibrations. And finally, authorization to perform any intermediate checks. If considering bringing calibrations in-house, there are general steps for implementation. These steps are just suggestions and not the way that you would have to do it. Your laboratory needs to evaluate risk and the context of your organization to determine the feasibility and the steps needed to bring calibrations in-house if applicable. The first step would be to determine what measuring equipment requires calibration. This step is important for all laboratories, for outsourced calibrations or in-house calibrations. When bringing calibrations in-house, you would develop procedures for calibration of the identified equipment. You would then purchase the necessary equipment and standards for traceability of calibrations and train personnel to perform the calibrations. Again, it is important to consider the risk and cost of each step when determining if calibrations would be outsourced or in-house. There are many different resources for the development of calibration procedures that calibration service providers use. The first and most obvious source would be the equipment manufacturer. NIST's Office of Weights and Measures also provides general calibration procedures for laboratory equipment. There are many ISO standards that provide guidance on calibration of equipment as well, and other NMIs could offer guidance on calibration of equipment. There are other standard developer organizations, such as ASTM, that write calibration methods as well. When looking at equipment and standards for traceability, you want to consider the measurement standards, the reference materials, any relevant reference data, and any software that's needed to perform the calibrations. The equipment and standards used for calibrations must be traceable to national or international standards. This traceability is ultimately to the SI or a stated reference. Oftentimes in the United States, we use NIST because NIST is our NMI. Additionally, CRMs or SRMs, which are standard reference materials, should be used where appropriate and available, as well as reference measurement procedures from an SDO or other qualified source. If performing calibrations in-house, it's important to ensure that there is segregation between reference standards and working standards. As best practice, there should be separate traceability for the reference standards and the working standards. We provide an example here where reference weights are used to calibrate a balance per a documented procedure. Working weights within the laboratory are used for intermediate checks to maintain confidence in performance of the balance. These weights are different and have separate traceability chains associated with the weights. When looking at traceability using reference materials, it's important to understand the difference between reference materials and certified reference materials. Reference material is a generic term. Reference materials can be used as secondary checks, quality control, system suitability, and verification checks, as well as other purposes in the laboratory. Most reference materials are accompanied by a product information sheet. Certified reference materials, on the other hand, are a subset of reference materials. They establish metrological traceability through a certified value with an associated uncertainty. They're accompanied by a reference material certificate, certificate of analysis, or other named document that designates the certified value, the metrological traceability, and the associated uncertainty, along with other required elements. I mentioned a couple slides back SRMs, or standard reference materials, so I wanted to give a little explanation of what SRMs are. SRMs are considered a CRM issued by the U.S. National Institute of Standards and Technology, or NIST, that also meet additional NIST-specific certification criteria. These are issued with a certificate or certificate of analysis that reports the results of its characterization and provides information regarding the appropriate uses of the material. SRMs are considered CRMs. When establishing metrological traceability, whether for the measurements and tests performed or calibrations performed, only CRMs, including SRMs, can be used to establish metrological traceability of those measurements and calibrations. This is something to keep in mind when considering the risks and costs of bringing calibrations in-house. A general calibration process is shown here on this slide. Again, this is just for example purposes. It's up to the laboratory to determine the calibration process that they will use, and they should consult with their accreditation body requirements to determine if there are any required steps in the calibration process. Initially, you need to identify the contributions to measurement uncertainty. Then you calibrate the equipment, evaluate measurement uncertainty, generate your calibration records, label the measuring equipment, and update equipment records. It's important to understand what's required for those calibration labels. The calibration label allows users of equipment to readily identify the status of the calibration or the period of validity. Common contents of a calibration label include the equipment ID, the calibration date, the due date of the next calibration, and if applicable, a reference value or correction factor. One thing to consider as well is managing the calibration intervals. The intervals for calibration between one calibration and the next calibration should be based on risk. Things to consider are drift of the instrument, if there was a prior calibration that was failed as found, the frequency of use of the equipment, and any manufacturer's recommendations. The calibration intervals should be evaluated periodically to ensure that they remain appropriate. This slide would apply to all equipment in the laboratory requiring calibration, whether that calibration is in-house or outsourced. Now we'll move into the areas of risk for organizations considering bringing calibrations in-house. Most of these have already been mentioned previously. We have to consider personnel competence and the availability of personnel to perform calibrations. When we're looking at resource availability, we're not just thinking about personnel, we're also considering the equipment and standards that are required to perform the calibrations in the laboratory. Metrological traceability is another source of risk. The organization must understand the importance of metrological traceability and how to establish traceability for the calibrations being performed. And then finally, record keeping is slightly different for calibrations than it is for testings and measurements. You want to make sure that you have appropriate record keeping processes in place to have the calibration records readily available that are required by the standard. There are ways to mitigate or manage these risks as well. If considering bringing calibrations in-house, you may want to consider dedicating personnel and other resources specifically to the calibration program. You'll want to document and implement the calibration procedures and review them periodically to ensure that they remain up to date. You'll want to manage equipment and standards for metrological traceability and measurement uncertainty, and record the calibration data and results on controlled forms or in equipment management systems. There are some limitations that we've discussed previously for in-house calibrations, and competence of personnel is the first one. Ensuring that personnel have the competence to perform the calibrations and understand metrological traceability and measurement uncertainty is important if bringing calibrations in-house. We also ensure that there are appropriate procedures. If the procedures are not robust, the calibrations would not meet the requirements of the standard. There also may be issues with the availability of traceable equipment and standards, and again, record-keeping challenges. That brings us to the end of the webinar. Before we move into the Q&A, I want to go through some of the additional resources that ANAB has available for accredited laboratories or laboratories seeking accreditation. We have many different media to further your understanding of standards, accreditation, management systems, and assessments. On the ANAB website, we have free webcasts on a variety of topics. These webcasts are 5 to 20 minutes long, depending on the topic, and can be viewed at any time. ANAB also has a blog page with a wealth of information related to risk, accreditation, standards requirements, and other topics. We also host these webinars monthly. Our next webinar will be right at the beginning of November on the topic of IAF and ILAC. We are also going to offer a second webinar in November on the updates to the 17065 standard. And finally, we offer training in many different areas, including internal auditing, standards, risk, and other topics. Most of our trainings are offered live online. We have web-based, self-paced training as well. We also offer private training that can be customized to the needs of your laboratory. All of these resources can be found on the ANAB website at anab.ansi.org. Now we'll get to your questions. We've had a few questions come through. If you have any, go ahead and enter them into the chat. And I'm going to invite Patrick and Chris to join us in answering these questions.
Yes, thank you so much, Melanie, for all that information. I've been writing down and thinking of some answers to the questions in the chat. Melanie, it looks like this most recent question, PowerPoint available for download, would be to you. I believe you said that this will be posted. This recording will be posted online, correct?
Correct. So we will post the recording of this presentation on our website within the next couple days once the recording is available.
Okay, perfect. Thank you. So yeah, I took notes on some of these questions that have been popping up in the chat throughout. And I will try and answer some of them right now and then get back to some specifics. But broadly, ANAB does allow for in-house calibrations. Each applicable accreditation requirements document. So that could be a number of different series depending on the type of laboratory that you are. So AR 2250, 51, 53, and then there's also ones for forensics and medical. But broadly, those should cover your requirements for in-house calibrations. And I also had a question asking if you had to be accredited to perform the calibration. You do not. It would fall under your quality system as an activity that your lab is performing, but it would not need to be listed on your scope of accreditation separately. I see here, so I think that answers, Dan, your question on that. Oscar, yes, this only applies to accredited laboratories to ISO 17025. Then Anna, I believe you asked about competence records and if annual proficiency testing would cover that. Competence records, I believe, in the context that Melanie was talking about, was records of competence and authorization for the lab staff to perform the in-house calibration. So you would have a procedure that the staff would be trained to perform the in-house calibration and a record of that. So I believe that answers your question in the context of Melanie's, but the proficiency testing, maybe of other tests, could be used as evidence of competence as well.
Yeah, I was going to say proficiency testing for the calibration itself would be a fantastic way to demonstrate that your personnel are competent to perform that type of calibration.
Mm-hmm. Yep, but yeah, the record of them having performed it wouldn't necessarily on its own provide the authorization. You would otherwise have to define that within your quality system.
Absolutely.
Yep. Then I believe there's also a question about GCMS specifically. So for any tuning process for equipment, that would generally fall under maintenance. So I know that you might be using reference materials or certified reference materials in tuning or equipment maintenance. So that would fall under equipment maintenance requirements. But the actual the traceability is coming from the CRM in this particular type of technology when you're running the test samples with the CRM in a run. So you're not really calibrating some of those complex equipment in the ISO 17025 sense. That would be maintenance, though it does involve traceable materials. Then the difference between calibration and validation. Paul, I'm not super familiar with load cells in particular, but generally, and Patrick, feel free to chime in at any point, there can be a lot of overlap between what a calibration and a validation is. I was just having this conversation with a laboratory 2 days ago, actually, and it is defined within the ISO structure to some extent, but it also can be laboratory defined to some extent as well. So my interpretation is a calibration is whenever you are potentially going to make adjustments to a piece of technology to bring it back into spec, whereas a validation is confirming that that equipment is at spec. Patrick, would you agree with that broad interpretation?
Yeah. Yep, that's exactly how I would describe it.
Yep, so some laboratories you might call that validation step a calibration. That isn't inherently incorrect, but that validation where you're confirming that your equipment is meeting spec would be a validation of the equipment. So I believe that was most of the questions that came in before the end of the presentation. So I believe a lot have come in since then. I don't know.
I can read them off to you.
Okay, yeah, I'm scrolling and looking. I'm just don't know
It's
what
hard
the best
to keep
approach is to to kind of hit them one at a time, or see if
one of the questions that came in that I'm not sure that you answered, it says, am I correct in understanding that 17025 allows for in-house calibrations, but ANAB does not for 17025 accredited testing labs?
Yeah, yes, I kind of spoke to that at the beginning, but yeah, ANAB does allow for in-house, and as per 17025's allowance for in-house. So in each of those accreditation requirements documents I had mentioned, as applicable from ANAB, those would have the requirements for the in-house testing for us. So particularly AR 2250 would be the most useful document I could refer you to. Accreditation requirements 2250 is that document where we state that we allow for in-house calibrations.
Okay. And then another one is, does ANAB consider the 1-point calibration usually listed in equipment manufacturer manuals as an in-house calibration, or is that considered an adjustment or something other?
That's a great question. Broadly speaking, for equipment, I would say, and I know it's not the most useful answer all the time, but it depends on how your laboratory defines that. And then as an assessor or auditor would come in, they would determine if that is technically sound enough of a procedure to meet the requirements of the testing that is being performed. So a simple test that I think is kind of maybe not everybody here is performing, but might be able to understand is something like a pH meter, where the manufacturer might provide a reference material to do a 1-point test and call that a calibration for that equipment. But if you're testing in a range of different pHs, it might be appropriate to test across or at the ends of the spectrum of pH that you'd be testing to establish a greater range of calibration. So I know that's a specific piece of equipment, but broadly speaking, it is the lab's responsibility to define the appropriateness, and then it would be your accreditation body and assessor's responsibility to determine if that is technically sound as a procedure. So it could be depending on the equipment and the manufacturer's method.
All right, thank you. And then the next question, at what point does the intermediate check result become a point of concern requiring immediate calibration?
It's dependent on the lab's defined risk for that test. Yeah, there's no one answer to solve that. So it's completely dependent on the laboratory's defined criteria for their intermediate result or intermediate verifications.
That's what I was going to say. It depends.
It depends, yes. And so, yeah, ideally the lab would have established trending data for what intolerance and out of tolerance is, and then have documented points at which, yeah, that would require intervention of recalibration.
Are there any resources that you can provide, or I wouldn't say recommend, that you can provide for the different classes of reference versus working weights?
Patrick, do you have anything from the proficiency testing side you can think of?
Well,
I could speak to it, but in terms of, yeah, resources, I don't know.
Yeah, I can't speak to resources. And again, it's all dependent on what you're testing. You know, what are your tolerances? What is your measurement uncertainty? How I don't want to say accurate, but how precise and accurate, I guess, does your result need to be, including its uncertainty? You know, if you're calibrating something that you're at the very far reaches of your equipment's capability, then you probably need a pretty strict uncertainty. So that would be where I would start off, is, you know, how how much uncertainty do I want to include in this?
Okay.
Absolutely.
Yep.
Another question I saw come in was, is there a detailed ANAB course for uncertainty budgets? Melanie, I believe the answer is yes, because I've taken it previously. I don't know about as of today what the schedule is, but I believe we do have a course on that.
Yes, we do. We have two different courses. We have a measurement confidence fundamentals course, and then we have a measurement uncertainty practical applications course. And both of those are open registration or can be private courses, and they are instructor led. You can find that information on the ANAB website under training.
Perfect, thank you. And then
go ahead.
Go ahead. Yep. If you have another question, I'm just reading another one, which might be the same one that you're on, but yeah, happy to answer.
I do. One had, do you have any general tips or info on how this applies to digital forensics? And I was just going to tune them into the AR 3125 for forensics testing laboratories. That's available on our website.
Yes, yeah. Thank you. Yeah, I'm not a forensic manager, so I was looking quickly to see what the AR number was for the forensic side for the 17025. For the non-forensic, that was the AR 2250 that I've referred to a few times.
Yeah, forensics is a bit different. A lot of their results are qualitative, or or on a scale. So metrological traceability isn't applicable because there's no specific quantitative uncertainty. So yeah, it would probably be best to discuss with your accreditation manager on the forensic side.
Okay, and then does ANAB offer training for in-house calibrations? The answer to that is no. We don't have specific courses on how to perform calibrations because it's up to the laboratory to determine the appropriate method for calibrating that equipment. That's why we referred you to ISO standards, and there's ASTM standards, equipment manufacturers, NIST, and other NMIs as well. Then the next question is proficiency testing necessary for in-house calibration for testing laboratories?
Yeah, that's a good question. Currently, in AR 2250 is not required, but as Patrick said earlier, that could be a great way to show that somebody in the lab is proficient to perform that type of calibration. So it is not currently required, but it is certainly a option that you have to prove and document that competence.
Okay, then the next question is about providing an example of the uncertainty calculation for in-house calibrations. That is dependent on the equipment that's being calibrated and the contributions to measurement uncertainty. And we would recommend potentially taking our measurement uncertainty course in order to determine that appropriate calculation. And then the next one, what are the specific requirements to establish traceability for in-house calibration?
For establishing of metrological traceability.
Those are the requirements in the 17025 standard.
Yeah, they're listed in the standard itself for establishing metrological traceability.
And then as well as so yeah, the section in the AR 2250 that speaks to in-house testing, either directly references or references through it being in the same document. AR 2250 also speaks on traceability and the different, I guess tiers is one word you could use, tiers of achieving that traceability with direct reference through NIST or other NMIs to the SI being the highest form.
Excellent. And then I would say, instead of reading the specific question, do you have any resources or recommendations of where to go to determine the intervals for in-house calibration and intermediate checks?
Go ahead, Patrick.
I was gonna say you might check the BIPM or the JCT GLM. I think that's more on the medical side. But there's a lot of resources out there and professional organizations that have guidance on this topic. I think the OIML is also another one.
Yes, that's another good one. Correct. And then that is also applicable to the question about developing acceptance criteria for calibrations and verifications, as well as looking at those same resources.
Yeah, and I think Eurochem might even have some guidance documents out.
And the equipment manufacturers might also, not in all cases by any means, but might be able to provide or will provide that.
Then there was a specific question about a specific tool in digital forensics, and I would recommend the asker of that question to reach out to your accreditation body, your accreditation manager, to ask that specific question. It's kind of outside the scope of our webinar today. Then the next question is, could you elaborate more on the difference between calibration and verification? I think you might have already covered this.
Yeah, I think we covered calibration versus validation. So again, it is defined, and the different labs can interpret it or use the words slightly differently and similarly. But so calibration is whenever you're adjusting the equipment to bring it into tolerance. A validation is when you're confirming that the equipment is fit for use and found in tolerance. So it's not just a daily check typically. A validation would be after a calibration has been performed or after maintenance has been performed, something like that. You are documenting that the equipment is fit for use and in spec. And then a verification would be likely more frequently performed, maybe daily, weekly, as a spot check for the tolerance. But you may not be looking at in the entire range. You might not be looking at all the aspects of the equipment's function as you would be in a validation, and then certainly adjusting in a calibration.
Yeah, that's great. To tie it into one of the next questions that I was reading, there was a question about glassware calibration or verification. That's, glassware can't necessarily be calibrated, however, it is verified or validated at certain levels because you can't make that adjustment to the glassware without compromising it.
Right, great. Then we've got a little question that requires a little background before the question. It says, we have a Capture 17025 testing laboratory and a separate calibration lab that is not accredited to 17025, but complies to 9001. The calibration lab uses certified reference materials that are certified on a set schedule by a third-party 17025 lab. So you may want to address that question. And then it asks, can we have calipers that are used as accessories to our 17025 tests calibrated internally by our calibration lab, or do they need to be sent out to a third-party lab?
Thanks, Melanie. I had read that one and I wasn't able to read it fully enough to, while also answering some questions to address it. If I'm understanding correctly in this situation, there is the accredited testing lab and a separate unaccredited calibration lab that uses accredited materials that could calibrate, was it calipers? Yeah, calipers for the accredited 17025 lab. So if I think I understood that correctly, we've come across this pretty frequently as assessors, Patrick, and I think you would agree to this, that many times calibration providers, so it sounds like in this case this is maybe both are your laboratories, but say you're using a commercial calibration provider, the commercial calibration provider may use accredited and traceable equipment to perform your calibration, but if they're not performing an accredited calibration or providing an accredited certificate and only complying to 9001, that does not meet the traceability requirements of 17025. You need to have the accredited traceability going all the way back, and if it's only 9001, that breaks the unbroken, or that breaks the chains of making it unbroken chain of traceability. So if I understood the question correctly, it would be no, that 9001 lab could not provide caliper calibrations to the laboratory if it's being used for accredited testing.
And I don't want to dive too deep into the calibrations lab's use of certified reference materials, but I do want to just make everyone aware that there's a bit of a misnomer with the description of a certified reference material versus, say, a reference standard. So calibration labs often use reference standards, similar to like your check weights in your laboratory for verifying your balance. Those are reference standards versus certified reference materials based on the ISO definitions. So just be aware of that reference standard typically deals with an item that is calibrated, whereas certified reference material, is typically it's like a solution or a soil matrices, or could even be a neat powder, something along those lines.
All right, great. Then we had a follow-up question about weight classes, and I was just going to point that individual to the International Organization of Legal Metrology, OIML. Also, ASTM and NIST also defined weight classes. It looks like Class A, Class F would be NIST, so you may want to take a look at that. Go to the NIST website and take a look at their classes of weights there. We're getting to the end here. I think you've already answered that one about glassware. It says, when defining calibration intervals, does 17025 have a suggested method? I'm looking at NCSL document RP1, but wanted to know if ISO has something.
No, the standard doesn't have any recommendations in it.
And I don't believe off the top of my head I'm aware of any guidance either for calibration interval that ISO has published.
NCSL is a great spot though to look for that guidance.
And then there's a question here, I'm not sure that I quite understand. Top-down measurement uncertainty can be accepted for in-house calibration measurement uncertainty, or the bottom-up budget mandatory?
Yeah, I read that one and I was not sure what that meant. I don't know if Mohammed, you're able to maybe rephrase in the last few minutes here and we can address it. But I'm not sure what you mean by top-down or bottom-up budget.
Right, that was my confusion as well. And then the question here, if a certificate for a CRM does not say it is NIST traceable and does not have an ANAB logo on it, but only lists the SRM, does that suffice as NIST traceable?
The answer is it depends, but in and of itself, just listing an SRM would not necessarily. Again, it could be something like a 9001 laboratory providing that certificate, and that is not accredited, so that might not be traceable, but it could. It depends. Patrick, do you have more to add?
Yeah, it depends on a lot of different things. You know, as on a basis of 17034 requirements for classification as a certified reference material, it needs to have a certified value, associated measurement uncertainty. It needs to have a statement of metrological traceability. And if it does not have those things, it also is required to have a certifying, what's the individual's name? A certifying officer's name. That would be a certificate for a lot of discussions if it only lists the CRM. Or if it only lists the SRM, my apologies.
Okay, great. We did have a couple other questions come in that were to specific equipment for specific processes and specific calibration methods. For specific equipment questions like that, as Chris and Patrick have stated, is to consult with your accreditation body or your accreditation manager and or your assessor to determine best fit of that calibration in your in-house or outsourced calibrations. We had another question that came in that asked, what is the main differentiator for in-house lab accreditation? That would be referring to our accreditation requirements and the 17025 requirements. I want to thank Chris and Patrick for joining us today to answer all of your questions. We spent 30 minutes answering your questions. If you do have any additional questions after this webinar about the training that we offer, our accreditation services, or just general questions about the 17025 standard or your laboratory's accreditation, you can contact us at training@anab.org or anab@anab.org. And if you have a specific question for Chris or Patrick, I can get those over to them as well. Thank you so much for coming to this webinar. We appreciate you joining us in learning information about in-house laboratory calibrations for testing laboratories. I hope everyone has a great rest of your day.